Hello guys, how are you today? So today I'm going to be explaining Chapter 2 AS Chemistry course revision questions from 1 until 20. Define saturated hydrocarbons. What does it say in the answer key? It says saturated hydrocarbons are organic compounds composed only of carbon and hydrogen atoms bonded by sigma bonds that have all hydrogen atoms possible. So in the AS, if they asked you to define saturated hydrocarbons, you would say saturated hydrocarbons are organic compounds composed of carbon and hydrogen atoms bonded by sigma bonds that have all hydrogen atoms possible. We'll move on to question number 2. What does it say? Heptane undergoes a chemical reaction according to the following chemical equation. What does it mean, heptane? Heptane is C7H16, right? It will undergo what? It will undergo this is cracking. How did I know it was cracking? Because from a larger alkane, it formed what? It formed a smaller alkane in addition to an alkene, okay? So cracking is when we take a larger alkane and we break it down into a smaller alkane in addition to the alkene. Give the molecular formula of compound X. Now this you need to do a little bit of math. So it's gonna be a CnH as well. 7 minus 2 is 5. 16 minus 4 is 12. So it's C5H12. Give the IUPAC names of the products of the following reaction. So when they say IUPAC names, that means when they say this, that means they want the universal name, which means the name of this and the name of this. This C2H4 has a name which is what? Which is ethene. And this C5H12 has a name which is what? Which is pentane. Okay, we move on to question number 3. What does it say in question number 3? Draw the skeletal formula for the product obtained. What's happening in this reaction here? We have an alkene over here. What's happening to this alkene? This alkene is what? Is C. So this alkene is C4, right? Let me just draw everything. So this is C, H, and H. So C4, H, 1, 2, 3, 4, 5, 6, 7, and 8. C4, H8. Okay? Now what happens? What did they do to the C4H8? They added hydrogen to it. So what will happen? It will break the double bond, right? So now the double bond breaks, and this carbon will get a single bond, and this carbon will get a single bond. So now it's what? It's like this, because it's gonna be a carbon, another carbon, another carbon, another carbon. But this has 3, this has 2, this has 2, and this has 3 as well. Now this is the skeletal formula of the product, right? So this is what? The hydrogenation of butene. What happened to butene? We added H2 to it, and what did it give us? It gave us butane. Now what is the IUPAC name? They want the universal name, so this is gonna be what? This is gonna be butane. Determine the functional group present in the reactant and the product if there are any. In the reactant we have a double bond in the reaction, in the reactant, and for the product, it's an alkane, so it's the simplest form of hydrocarbons found in nature, and it does not have any functional groups. We'll move on to section 2.2, which is about reactions of alkanes and free radical mechanisms, okay? So octane, C8H18, is a key component in gasoline, which is a fuel used in combustion engines. What did they tell us? They told us give the chemical equations for the complete and incomplete combustion of octane C8H18. First of all, let's deal with the complete. What was the equation for the... hold on, I have the equation in my copybook, in my notes. Okay, the complete combustion of an alkene the complete combustion of an alkene. First of all, an alkene will have the formula of CnH2n plus 2. And in addition, we will have 3n plus 1 over 2 oxygen, which will give us what? Which will give me NCO2 in addition to n plus 1 water. This is the complete combustion. For the incomplete combustion, what is it gonna be? It's gonna be CnH2n plus 2 in addition to 2n plus 1 over 2 O2, right? Which will give me what? Which will give me NCO in addition to n plus 1 H2O. So, what does that mean? That means I have C8H18, right? So, C8H, how much? H18. That means my N is how much? My N is 8. Right? So now I substitute all of my N's with 8. Okay? So what will I get on my calculator? This is C8H18 plus 3 times 8 plus 1 over 2. This will give me 25 over 2. I keep on dropping my pen, my bad. 25 over 2 O2, which will give me what? Which will give me 8 CO2 in addition to how much? To 9 H2O. Now I have a problem here. I cannot keep it as a fraction, so I need to multiply everything by 2. If I did multiply everything by 2, I'd have 2C8H18 plus 25 O2 will give me 16 carbon dioxide in addition to 18 water. Now for the incomplete combustion, we have, let me change the color, C8H18 in addition to 2 times 2 plus 1 over 2. O2 will give me 8. Sorry, 2 times 8. Here it's 8, not 2, my bad. Because you replace the N with 8. And then, what do you have over here? 8 plus 1 times H2O, right? So, how much would this be? It would be 2 times 8 plus 1 over 2. So, it would be 17 over 2. Again, it's over 2. We can't let it stay as a fraction. So, what will I do in this scenario? I will multiply everything by 2. So it should be 2C8H12 plus 17O2 will give me 16 carbon monoxide in addition to 18 H2O. Okay, so this is the complete versus the incomplete combustion. Part B, identify the consequences of the incomplete combustion products on health. Okay, incomplete combustion products, we have carbon monoxide. What does carbon monoxide do? Carbon monoxide has what? We can say hemoglobin. This is better. Hemoglobin has a greater affinity to CO than O2, right? So when inhaled, carbon monoxide will bind to hemoglobin, okay? So you will say when inhaled, carbon monoxide will bind to hemoglobin. And what does inhaling carbon monoxide do? It will cause one to feel dizzy and lose consciousness, like he will pass out. Okay? And if he's exposed to so much amount of carbon monoxide, he might result in asphyxiation and he might die in like severe cases, okay? Now, in part C, what does it say? It says, write the chemical equation by which the toxic gas produced by incomplete combustion of octane is converted to a large harmful gas in the atmosphere. In many cars, they have this process, right? What do they do in this scenario? They add oxygen to the carbon monoxide, which is the toxic gas produced by the incomplete combustion. So carbon monoxide, you will add to it oxygen to give you CO2. Now, it's not balanced. How do you balance it? You put a half over here. Of course, you cannot leave it like this. So it will be 2 carbon monoxide plus O2 is gonna give me what? Is gonna give me 2CO2. Okay, that's it for part C. We'll move on to question number 5. What does it say in question number 5? Catalytic converters are installed in car exhaust to remove mainly 2 pollutant gases released from internal combustion engines. Write the chemical formulas of the gas pollutants that are converted into less harmful gases in a catalytic converter. So we have some pollutants that are converted into less harmful gases, and they are mainly nitrogen monoxide and carbon monoxide. Write the chemical equation by which the above gases are converted. So we have carbon dioxide and nitrogen monoxide are added together, right? So carbon monoxide is added to nitrogen monoxide and they're both gases, okay? What happens? It will produce 2 carbon dioxide, or no, without the 2, it will produce carbon dioxide, which is also a gas, in addition to N2, which is also a gas. Now, carbon monoxide, nitrogen monoxide are more harmful than carbon dioxide and nitrogen 2. Even though these are still harmful, it's not as harmful as carbon monoxide and nitrogen monoxide. Now it's not balanced. How do you balance it? It will be 2CO plus 2NO will give me 2CO2 in addition to N2. Part C, what does it say? Which of the following is another gas pollutant that is converted in a catalytic converter? We have the VOCs, very important. They're very dangerous that are converted in the catalytic converter. Okay, and we'll move on to part D. What does it say? It says, what's the name of the catalyst used in the catalytic converter? The catalyst used in the catalytic converter is platinum. Nitrogen monoxide is one of many gases released from an internal combustion engine. What condition leads to the formation of nitrogen monoxide in an internal combustion engine? This condition is what is high temperature. Okay, now part 2, write the chemical equation of the reaction that leads to the formation of nitrogen monoxide in a combustion engine. So it's gonna be nitrogen dioxide, which is a gas, will react with O2 gas under severe temperature and pressure. And it will form what? It will form 2 nitrogen monoxide gas. Ignore that. We'll move on to question number 6. What does it say in question number 6? Methane, CH4, can react with bromine under certain conditions. What's an essential condition for this reaction to occur? So look what's happening. We have methane, which is what? Which is an alkane, will react with a halogen. So what is this? It's a halogenoalkene. It will form a halogenoalkene by a method called what? By a method called substitution. What are the conditions for substitution to occur? We need UV light or sunlight. And what do we need? We actually mainly only need UV light and sunlight. Now, what is this type of reaction? Whenever you see halogenation of an alkane, you directly say this is what? You directly say this is free radical substitution. So it is a free radical substitution. We didn't take any free radical addition, and we didn't take any of these for the alkane. We're gonna move on to part C. What does it say? It says the mechanism of the reaction is divided into 3 main steps: initiation, propagation, and termination. Fill in the blanks with initiation, propagation, or termination to identify each step of the described mechanism. So initiation is the initiating step, and usually in the initiation step, what happens? The energy from the sunlight breaks the Cl sigma bond homolytically, so it will form what? It will form 2 Cl free radicals. So this is my initiation step. We move on to the next step, which is what? Which is the propagation. We have 2 propagations when it comes to this. So directly, whenever you see 2 equations, you will know directly that this is what? That this is my propagation. Now, my termination is when I have 2 free radicals that come together to form a product. Okay, so my termination is when 2 free radicals come together to form one product without any free radicals. So that's it for section 2.2. Now we reached section 2.3, introduction to alkenes. Define unsaturated hydrocarbons. How do we define unsaturated hydrocarbon? Unsaturated hydrocarbons, HCS means hydrocarbons, are organic compounds made of carbon atoms with at least 1 carbon-to-carbon pi bond, which is either a C double bond C or a C triple bond C, okay? So how do you define unsaturated carbons? Unsaturated hydrocarbons are organic compounds made of carbon atoms with at least 1 CC pi bond, which means C double bond or C triple bond. We move on to part 8. What does it say in part 8? In part 8, we have butane 2-ol can undergo in the presence of Al2O3 and heat according to the following reaction. So, butane 2-ol is what? Is an alcohol. Alcohols are heated in the presence of a catalyst, more specifically Al2O3, or porous pumice or concentrated acid. Okay? Now what happens? The CH and the COH bonds break. So, this is what? What do we have? We have it like this, right? So they're telling us what happens is that the CH bond breaks and the COH bond breaks. So we have two bonds broken, meaning we can either have a double bond like this, right? So it could look like this. Or it could be from here, you can break this bond and this bond, and you can form the double bond like this. Or it could be like this. So what happens? It eliminates a water molecule, and what do we have? And we have a double bond from where the OH is. So we have OH carbon. That means with this carbon it will form a double bond, or with this carbon it will form what? It will form a double bond. So it will either form but 1-ene or but 2-ene. We'll move on to part B. What does it say in part B? Bromocyclopentane undergoes the following reaction. Give the systematic name for the product X that forms. When you're heating, when halogenoalkanes are heated with what? With, first of all, bromocyclopentane is what? Is a halogenoalkane. When halogenoalkane is heated with ethanolic NaOH, okay, what happens? We will have an alkene that will form. Now what happens? Basically, what happens in this deep step-by-step process is that bromocyclopentane is what? Is what is bromocyclopentane? Let me just double check. Bromocyclopentane is C5H9Br. Now what happens is, I'm just going to explain it very briefly, like how it happens, so it will, like, you guys can remember. The NaOH in ethanol, usually NaOH forms Na plus and OH minus, and usually we would consider this as a nucleophile, meaning it loves electrons. It loves nucleus, the positive, right? So whenever we have a nucleophile, it will undergo substitution, right? Because it's an alkane. Alkanes undergo usually substitution. But we're not considering it as a nucleophile. Why? Because it's dissolved in ethanol. When it's dissolved in ethanol, we will take it as what? As a base, right? So if it's acting as a base, it needs to be neutralized, meaning it needs to form what? It needs to form water. So what's missing is an H+. So let me draw just the termination, right? I have carbon, hydrogen, Br, carbon, hydrogen, and then I don't know what there is here. Okay, so this is what it looks like, right? This is Br. What happens is my OH minus comes here, right? It's like, you know what? Let me grab this hydrogen and it will come with me. Okay, OH minus. Now, this wants to form what? Oh, sorry, no, I took it from the wrong place. Please ignore that. I took it from the wrong place. The OH minus does not come on the carbon with the Br. It will never, ever come on the carbon with the Br. Good thing I remembered. It should come here. OH minus to any other carbon without the Br, but that's close to it, right? So that means OH minus will come here. It will grab the hydrogen. It's like, come with me. We'll make water. They made water. Now this wants to form what? Wants to form a double bond. But in order to form a double bond, it needs one more single bond from where? From this carbon over here. Now, this carbon tells the hydrogen, the bromine, and the other hydrogen, one of you guys need to leave one that's the largest, most stable ion. Bromine's like, you know what? I'm gonna leave. And it packs its stuff and it leaves. And it will leave what? A single bond. In order for what? In order for them to form a double bond. Okay, so what happens is that we lose the Br and we lose one hydrogen. So it will be C5H8. Now this is what? This is cyclopentane. How did I know? It's cyclopentane. I just removed my bromo, right? And then I'm left with cyclopentene, my bad. Cyclopentene, not cyclopentene. Cyclopentene. How did I know it's cyclopentene? First of all, I removed my bromo. Second of all, it's still a cyclo, right? It's always gonna stay a cyclo. Pent, because I have 5 carbons, and now it's ene because I formed what? I formed a double bond, okay? So that's it for 2.3. We'll now move on to 2.4. So we move on to section 2.4. It's about reactions and the reaction mechanisms of alkenes. Now, what does it say? It says consider the following. What do we have over here? We have but1-ene, right? But1-ene. What happens to the but1-ene? It will become into butane. How does this happen? This happens by the hydrogenation of but1-ene. So the hydrogenation of an alkene will give you an alkane. So you need to do H2 in the presence of what? In the presence of platinum or nickel. So platinum or nickel and what? And heat. It would give you what? It would give you an alkane. We'll move on to question number 10. Some useful compounds can be industrially produced by reacting alkenes with steam at high temperature and pressure in the presence of a catalyst. So, I'm going to open my notes really quickly. What is this? We are doing what? We are reacting alkenes with steam at high pressure and temperature. Okay, so this reaction is when alkenes are hydrated. Alkenes are hydrated when heated with steam under really high pressure and temperature and the presence of H3PO4. What is H3PO4? It's concentrated phosphoric acid. So the catalyst used is concentrated phosphoric acid. Suggest the skeletal formula for the organic compound obtained if 2-methyl-but1-ene reacts with steam at the conditions mentioned above. Let us draw 2-methyl-but1-ene. First of all, we draw what? We draw but1-ene, and then what do we draw? We draw 2-methyl. So here. Now, it reacts with what? It will react with steam, so plus H2O gas steam, in the presence of H3PO4, 300 degrees Celsius and 60 atmosphere to produce an alcohol. Now, how will the alcohol produce? It could be how? We'll break the double bond, right? And what happens when we break the double bond? We'll have the addition of a hydrogen over here and the addition of an OH group over here, or the other way. It doesn't matter, so as long as you put them like this. But you don't include the hydrogen. So what should your product become? Your product should become like this. And you have this on top, and then you have OH over here. Or it could be like this, and then you have what? You have this here, and you have the OH over here. Now, name the organic compound you represented. What is this organic compound? This is, first of all, 2-methyl, right? Then it's butane, and then where's my hydroxyl group on the second carbon? Butane, 2-ol. Or the second one is what? Is 2-methyl. Where's my hydroxyl group on the first carbon? So butane, 1-ol. To which homologous series does it belong? It belongs to alcohols. We move on to question number 11. Label each carbocation as primary, secondary, or tertiary. You need to look where? You need to look and you need to see if the carbon is attached to 1 or 2 or 3 alkyl groups. For example, here, this carbon is connected to 1, 2, and 3 alkyl groups. That means this is what? That means this is tertiary. This carbon over here is connected to only 1, so this is primary. And this carbon over here is connected to 1, 2, so it's a secondary. Now they said arrange the given carbocations in increasing order of stability. Tertiary is more stable than secondary, is more stable than primary. Okay, we'll move on to question number 12. when propene C3H6 is bubbled through a concentrated solution of hydrogen bromide. Okay, at room temperature a reaction occurs. So whenever we have an alkene and then we have anything with a halogen, what type of reaction will occur? A hydrohalogenation reaction will occur. Now, this type of reaction is called what? It's called an electrophilic addition. So, an alkene in the presence of a halogen, what will happen? It's a what is called again? It's called a hydrohalogenation, or in another term, electrophilic addition. We'll move on to part B. Which of the following is the intermediate formed in the course of this reaction? Okay, so what did they say? They said C3H6. So that means we have C, can have the double bond over here, single bond over here, and then we have what? We have H6. So 1, 2, 3, 4, 5. 4, 5, and 6. So it's like this. H, and H. Then what happens? Then we have HBr. The slightly positive hydrogen will be attracted by the double bond, because the double bond is what is nucleophilic. It has an excess of electrons, so it's nucleophilic. Whereas hydrogen, which has a lack of electrons, is electrophilic. So what's going to happen is it will be attracted to the double bond. So it will go from here to here. Then what happens is we will form a compound like this, which is C, single bond C, single bond C. And then what do we have? We have H. And then the hydrogen will come over here. So we have HH. And then what do we have over here? We'll have the two bonds, right? Or no, the hydrogen won't come over here, it will come over here, but we will have this one to be what? To be positive. It will form a carbocation. So the correct answer is what? The correct answer is D. We'll move on to part C. Give the mechanism for the second step where the intermediate is transformed into the final product. Now what do we have after this? After we drew the carbocation, right? So what did we say? We have carbon, positive, hydrogen, and hydrogen, right? And then what did we have left? We had the Br minus, right? So the Br minus is going to be left with the lone pair of the electrons, right? From the HBr. And what will happen? This lone pair will go where? It will go to the carbocation. And what will it form? It will form C3H7Br. Okay, so what do we call this? It is 2-bromopropane. So what did we form? We formed an alkane, a hydrogen alkane, from what? From an alkene by the process of adding concentrated solution, and then it underwent what? It underwent electrophilic addition. We'll move on now to part D. Give the name, we named the major final product. Now, question number 13. Consider the following reaction. What do we have? We have 2-butene. What is this? An alkene, right? So 2-butene is like this. In the presence of Br2 and CCl4. Very important, the CCl4. What is the role of CCl4 in this reaction? CCl4 is the solvent in this reaction. Now what happens is that the Br2, right? So let's draw it. Draw the mechanism for the reaction that leads to the formation of X. Okay, so we have two steps. First step that we're gonna draw is what is the 2-butene. So we have butene 1, 2, 3, 4. So 2-butene is over here. And then we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Right? Now what do we have? We have that a Br, right? this Br will come close to the what? To the like the bonded pair, and the bonded pair is a nucleophilic, right? So it will push away these electrons where? To the bromine. Okay, so what happens now? The bonded pair will go to the bromine and the bond will go to the other bromine. Okay, so what will we be left with? We will be left with a carbocation, right? So we'll erase this. It will be a single bond. We'll have a hydrogen over here, and we'll have what? We'll have a carbocation. In addition to what? In addition to a Br minus with a lone pair. This was the very first step. The very next step to do is we take the lone pair from the Br minus and we'll take it to the carbocation. Okay, so we just draw an arrow like this, and then what do we end up with? We'll end up with something like this. Now let us name this. I put hydrogen in my bad. We were putting bromine. Don't put hydrogen. I put it by mistake. So how do we name this? It's gonna be 2, 3 because 1. This is 1, 2, 3. So 2, 3 dibromo because we have 2 bromides. Dibromobutane. Now what observation can be made during the reaction? Br2 is a brown or orange liquid. If it will undergo this reaction, it will form a single compound, and what will happen? It will decolorize. Okay, so the bromine solution is decolorized. We'll move on to question number 14. Give the chemical equation for the oxidation of 2-methyl pentoene with one of the following. Give the chemical equation for the oxidation of 2-methyl pentoene with the following, with first of all hot acidified KMnO4 solution. So oxidation reaction. Whenever we have KMnO4, and it will be an oxidation with the cold dilute acidified KMnO4, it will produce diodes. That means something that has 2 OHs, and the purple color of KMnO4 disappears. If it's oxidation with a hot concentrated acidified KMnO4, we're gonna have a couple of cases. First of all, let us draw what they gave us. 2-methyl pentoene. So first of all, let us draw pentoene. This is 1, 2, 3, 4, 5 pentoene, and then 1, 2 methyl pentoene. We add to it KMnO3. Okay, that's concentrated, that is heated, right? So what does the heated do? It gives us multiple cases. Now, it all depends on what? It all depends on the carbon over here, right? So this carbon over here, what do we have? We have CH3 over here and CH3 over here. So what does this mean? This means we have 2 R groups. If we have 2 R groups, then it's gonna form what? It's gonna form a compound that contains only this carbon and these 2 R groups with a double bond O. So what does it mean? This carbon, okay, over here, I'm just gonna draw carbon with these 2 groups, and then it's double bonded O. Okay, so this is what it's supposed to look like. In addition to what? In addition to anything remaining. So what's left is we have 3 carbons, right? So we have 1, 2, 3. Oh no, I drew it wrong. 1, 2, 3 carbons left. On this carbon, we will have an OH, okay? On this same carbon, we'll have a double bond O, and then on this carbon, we'll have H2, and this carbon will have what? We will have H3, okay? So this is what this is with hot acidified KMnO4 solution. Now, with cold acidified KMnO4 solution, we will produce what? A diol. Okay, what does it mean, the diol? So let me redraw 2-methyl pentoene. So 1, 2, 3, 4. Okay, 2-methyl pentoene, right? So what does this mean? This means methyl here. Okay. So what happens with cold acidified KMnO4? It will produce a diol, and the purple color of KMnO4 disappears. So basically, in the presence of KMnO4, we will have what? We will have addition of oxygen. So it gets oxidized, right? So it will be 1, 2, 3, 4. It will break the double bond, right? When it breaks the double bond, it will form another bond here and another bond here. And then here it will add an OH, and here it will add an OH. So this is what the final product looks like. In part AI, what did we have? For the first part in AI, we had something like this. Hold on. Let me just identify this first. What is this product called? This product is called a what? It's called an alcohol or a diol, because we have two hydroxides. Then, what was one of our other products? It was like this. One of our other products was like this. What is this? Whenever you have a double bond O and you have an R group here and an R group here, this is a ketone. So we had a ketone. In addition to what? In addition to a carboxylic acid, because it was COH, double bond O, so COOH, and then CH2CH3, okay? So this is what this is, a carboxylic acid. Now we'll move on to section 2.5. What does it say in section 2.5? Define non-biodegradable material. Non-biodegradable materials are substances that cannot be decomposed biologically. In other words, no microorganisms such as bacteria and parasites would digest them to remove them from the soil. Okay, so you need to say this. What are the harmful gases produced by burning polyalkenes? You have carbon dioxide and carbon monoxide, the main two harmful gases. We'll move on to 17 grid. Given below a species of a section of a monomer, which of the following is the repeating unit, right? You just need to check where it keeps on repeating. So you will come here and you will come here. So you will see that your repeating unit is this, because you will see that all the time. What's the repeating unit? CH, CH3, CH2. So it's gonna be what? The answer is supposed to be B. Now we'll move on to part B. It says write the chemical formula for the monomer that forms the given polymer. So I think it's wrong. It's supposed to be C2H. No, oh sorry, there's this carbon over here. I forgot about it. My bad. So C3, so 1, 2, 3, H3, so H6. Okay, so C3H6. What type of polymerization does it belong to? It belongs to alkenes polymerization, because it has the structure, or like the homologous or the chemical formula of an alkene. And what is the type of polymerization? The type of polymerization is the addition, because alkenes undergo addition polymerization to form larger alkenes. So addition polymerization. We'll move on to question number 18. What does it say? A section of an addition polymer is given below. Give the name and skeletal formula of the monomer used to prepare the given polymer. Okay, so I need to check my repeating unit. I have 1, 2, 3, 4, and 5. And then from here I have also 1, 2, 3, 4, and 5. So what can I say from this? I can say that it's gonna be cyclo, because first of all it's cyclic, right? So cyclo, and then how many carbons do we have? 1, 2, 3, 4. So cyclobutane. This is the monomer used to give the polymer. And then the structural formula would be what? It would be a square with what? With a double bond. So we're basically closing this, you know? Perfect. Now what does it say in part 2? It says incineration of this polymer releases CO2 in the atmosphere that causes environmental consequences. When environmental consequences, global warming, because the increase in CO2 production will cause the total Earth's temperature to rise, thus increasing or causing global warming. Part B, potassium permanganate is a purple solid with a low purity. It is a strong oxidizing agent that's used in many redox reactions as per the below chemical equation. State the full electronic configuration of the ion. Okay, this is easy. What's the electronic configuration of this? 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2 and 3d5. This is for regular manganese. But now, because we remove 2 electrons, we always remove it from where? From the s orbital, okay, whenever we have a d. So 1s2, 2s2, 2p6, 3s2, 3p6, and 3d5. That's my final answer. Number 2, determine the oxidation number of Mn in MnO4 minus. So let us do it. We have MnO4 minus. That means x plus 4 times minus 2 is equal to minus 1. So x minus 8 is equal to minus 1. X is equal to what? Is equal to 7. Describe the bonding in solid KMnO4. Because it's positive and negative, it's going to be cation and anion. So ionic lattice of positive ion and negative ion attracted by electrostatic attractions. Then we move on to part C. What does it say? It says to determine its purity, a mass of 100 grams of impure KMnO4 reacts with H2 C2O4 to produce 44 grams of CO2. So determine the mass of KMnO4. So if we go back up to the equation, we're dealing with what? With carbon dioxide and MnO4 minus. So finding the number of moles of what? Of MnO4 minus, you're going to divide it by the coefficient. It's equal to the number of moles of carbon dioxide divided by the coefficient, which is 10. So when you do cross multiplication, it's going to be 2 times the number of moles of carbon dioxide divided by 10. This is the number of moles of what? The number of moles of MnO4 minus. So to determine the mass of MnO4 minus, we need to find the number of moles of MnO4 minus. So it's going to be 2 times the number of moles of CO2. How do we find it? Mass over molar mass. So times 44 over 44. Okay. Divided by what? Divided by 10. So that will give me 0.200 to the correct significant figure, 0.200 mole. Now what can I do? I can find the mass of MnO4 minus by doing what? By doing number of moles times molar mass. So 0.200 times 158. This will give me 31.6 grams. So what would my percentage be? My percent of pure, the purity of KMnO4, it would be the mass over the mass of pure over the mass of the impure times 100, which is basically 31.6%. We'll move on to 19. And then 20. I think that's all I'm gonna do. I'm gonna leave the rest for you guys. Anyways, that's it for this video. Thank you guys for watching. I hope you enjoyed and have a wonderful